Okay, this is the problem that Mike told us, well, I really don't know what is going on. He looked very lost and didn't seem to like it. So I hope I can clarify everything. Um, this is a graphing tool online. So here's the problem. They don't really ask you for the graph. Actually, they do. It's below. I cut it off. So they give you a function that's called a rational function. This is number 7. It's called a rational function because it's a ratio of two polynomials. So you see on top I have a polynomial and the denominator I have a polynomial. I have a series of questions here. And we're going to answer those questions. We're going to be able to answer those questions and the whole problem without doing any calculations, actually. This is a graphing tool that's online called Desmos, which was shown to me by a terrific high school teacher, Mr. Putup, and you can see why I think it's nice. It's not like your graphing calculator because it automatically sets the window. You don't have to change the window so that you can entirely see the graph. From here, we can actually analyze the whole thing and answer the questions they want on Webassign. I already know what the graph looks like, so I can go and check off the multiple choice and give you the right graph. But they also ask you a series of questions. The first thing is, what's the vertical asymptote? The vertical asymptote is a place where there's a abyss and it's blowing up. The graph is blowing up before and after the abyss. And you can see here it's blowing up to plus infinity right before this abyss, and it's also going down to minus infinity right before after the abyss. So we call that a vertical asymptote. They also ask you for the roots, and the roots of the function are right here. But I can't really see it because it's all squished. I can't see what it is. So I'm going to zoom in. And what's nice about this graphing tool is it lets you zoom in by just clicking zoom in. And I can see that there's a root at 1, 2, and 3. And not only that, this graphing tool has put a nice dot there so I can see that it's a root because it's an important point. It has 2 more important points right here and here. They're what we call local maxes and mins, and that you learn about more in calculus. So I have 3 roots. They're x equals 1 and x equals 2 and x equals 3. Look, we're blowing through those questions on Webassign very quickly. The next question they ask you is about the Y-intercept. Y-intercept is where the graph crosses the y-axis. And I can see it's crossing somewhere here, but I have no idea exactly where. I need to zoom in right into that section. And I see that when I zoom in down in that section, I see that it's crossing right at -6. And it actually has given me a nice dot there to tell me it's crossing right at -6. So I wanted to show you what it looks like on your calculator. This is a tool online that simulates what it looks like on your calculator. You can even see how I input in the rational function. Notice that the entire denominator has been put in parentheses. If you don't type it in that way, it's not going to show up. So please type it into your calculator as you're watching this video so that you can look and see and compare what you're getting to what I'm getting. It gives me the default window, but unlike your calculator background screen is gray. It has your calculator, it has a black graph, and if you have Cassandra's calculator, it has a black spot on it as well. So what my point is, it's really hard to see on your calculator because it has it doesn't look as nice as this one even still. The 89s, Quasi's 89, will actually give you, I think, a color graph with a white background. So it's much better looking. But we can still see that there's a asymptote here. One thing I'd like to point out is your graphing calculators put a line here. And that's because it doesn't seem to recognize that there's a huge abyss here. It takes the last dot and the y that it gets up here and connects it to the dot that's down here. This is quite unfortunate because many students copy this graph when they're asked to graph something, and it tells the professor that the student doesn't know what's going on because they didn't know that there was an asymptote there, which is not a good thing. Don't do that. I don't want to see this line on your graph. You'll get points taken off for it because it's a side effect of not really understanding what's going on. So how do we zoom in like I zoomed in on the Desmos calculator online? Unfortunately, we have to change the window. For example, if I want to see down here? Well, I can see that there's roots, but I need to get in closer. So what I'm going to do is I'm going to change my window to, I'm going to change it to x min equals -1 and x max is 4. I also want to change the y window because it's too long right now. I want to go down and zoom in down here. So right around here, if I made horizontal lines, I'd want to look in maybe -8 to 4 just to capture this. So my y min would be -8 and my y max would be 4. And I plug them in. You see that now I have the window changed up here exactly as x min was -1, x max was 4, y min was -8, y min max was 4. I still can't see here. It's too squished. So I'm going to go 0 in closer. I'm going to go x equals -0.5, x equals 4, and y equals -1 to y equals 2. So I have a better looking window. I accidentally put in x equals -5 here instead of x equals 0.5, and I'm not sure why I did that, but it doesn't matter because now I can see the roots are x equals 1, 2, and 3. I can see them. So that's what you'll want to do, and I'm not going to go through the Y-intercept and all the other things because they're exactly the same as Desmos, except you have to now change your windows on your calculator instead of zooming in. So how do they intend you to do this problem? Unfortunately, the textbook problems are way behind what we can do today. So they want you to graph the function, the rational function, as if you can't see the graph. But you can't see the graph. So you would be an idiot if you didn't look at the graph. It's like saying, I would not like to see the answers first before I do the problem. So in my quiz, I'm going to ask you to draw the graph from your calculator. And then I'm going to ask you what your windows were that you selected so you can actually get in there. I'm going to put a template online so you can see what I have in mind. And so I'm going to want you to get the entire answer from the calculator first and then actually go through what we call the analytical, what they intended you to do. So this is way behind what I was calling old school. So step 1 for you is to actually graph the function and find all the answers that they wanted you to find on the tool, on the Webassign. And we did this already. The vertical asymptote is somewhere by x equals 0. I can't quite see where it is. The horizontal asymptotes are none. How do I know that? Well, as I said before, from the Desmos, you can see that horizontally, as I go flatten out to -infinity and +infinity, these things, the graph is not flattening with me. It's going up to +infinity on both sides as the graph stretches out in both directions. It would have a horizontal asymptote if it flattened out as we went out in both directions. So there are no horizontal asymptotes. There's a vertical asymptote somewhere by x equals 0. The roots are x equals 1, 2, and 3. The y-intercept is -6. How do we find the vertical asymptotes analytically? Well, we set the denominator equal to 0. Here was the original function. Set the denominator equal to 0, and I get x equals -1/6. Notice here, x equals -1/6 is the correct answer, which shows up on my Webassign but not yours. Then we need to know what the graph looks like around x equals -6. Does the y value go up or down? Does it go to heaven or hell, or does it both go to hell, or does it both go to heaven? So here's the possibilities. It could go up before the site and down after the site. They could both go down, blow up down, or they could both blow up, or it could go blowing up after the site and blow down before. How do we figure this out, which graph I select? Well, we choose an x close to the asymptote but bigger than the asymptote, like a little bit to the right of the site, and we also check a little bit to the left of the site. And I just use 0.01 to indicate just a little bit to the right and a little bit to the left. And I have the decimal values because they're easier to work with. So these are decimal approximations. Check the y values by plugging in. So here I made a little table. This is the x value. This is a little bit to the right, and this is a little bit to the left. And what I see is the y value is large and negative, so it's going to hell a little bit to the right. and it's going to heaven a little bit to the left. Goes down, goes up. And I'm using heaven and hell as an example because it's blowing up. It's not actually going to be a number. It's blowing up to infinity and negative infinity. So look at my possibilities of graphs here. Going to hell, going down a little bit to the right of the asymptote is this picture right here. It's going up and down, up and down. This picture is incorrect because this is going down, down. This picture is incorrect because it's going up, up. And this picture is incorrect because it's going down before, up after. So these three are wrong, and this graph on the left is correct. Find the roots. How do we find the roots? We set the numerator equal to 0. So the way we find the roots is set the entire function to 0, but the only way the function can be 0 is if the numerator is 0. So they set this one up. They made something easy for me. They set this up so I easily can find the roots. How do I find the y-intercept? You set x equal to 0. So isn't that nice? I can just erase the x's and replace with 0, and I get -6, as I already know. So it's matching what I just found on the calculator. Horizontal asymptotes are found by plugging in very large numbers into x. There's some really large numbers in both directions, but large in magnitude, large to the right, large to the left, and calculate the y value. You did this in class. I get huge and huge for y. That means that the graph goes to plus infinity as x gets large, and actually this is incorrect. It should be plus infinity as x gets negative large. So I had this completely backwards. So this is going up, growing to infinity as x gets large to the positive direction, and going to infinity as x gets large to the negative direction. It's 5:30 in the morning, so I have a right to make a little minus sign errors here and there. So here's how we piece together the graph. Here's what they wanted you to do. I have an abyss right at -1,6. So I'm going to make a little vertical line right at -1,6. From my information from the first table, I know that it's going up before and going down after. I also know that it has a y is crossing at -6. So I can even put in that piece there. I also know that there are 3 roots, so it must cross the x-axis at 1, 2, and 3. And I know that it goes to plus infinity here because the numbers were huge as x went to infinity. And I know that it goes to plus infinity here. The numbers were huge as it went to minus infinity. And that was the whole purpose of the problem. It's just that the purpose has been outdated. So we're going to redo it the way we should be doing it if we had a $150 graphing calculator sitting in front of us. So that's it. Happy weekend. These are the 2 problems that will be on your quiz, this particular one and the box problem that was before it.